Okay, let's get started. This is another repeatable DB creation demo. And I have the first item on the discussion. I just wanted to give everyone a quick update on what's happened since the last demo. Just read it. If you have any questions, put them below. I'm not going to go through it item by item because I want to jump right to the demo. For the demo, what we're going to be doing is creating a new database cluster in staging. And this will just be the infrastructure, not the configuration. We haven't gotten to the part where we're configuring the boxes yet. And this will bring up everything all the infrastructure, well, we think that we need right now, minus the ILB for the Patroni cluster. So that includes the Patroni nodes, the PG bouncer, and the console server. I'll start by sharing my screen. So this is the DB provisioning repository. Inside of this repository, there is a Terraform environments directory. You can see that there are 4 folders here. One of them is common for just common Terraform resources for all the environments. Then you have production, staging, and sandbox. We're going to create this in staging. First one I'm going to demo is creating the infrastructure locally, and then we'll show how it works by applying it in CI. So this is set up to use GitLab managed Terraform state. In order to use Terraform's or GitLab Terraform state, you have to do a special Terraform init, which points Terraform at the GitLab instance. So I have a helper script here. It's nothing fancy. It's just this, which basically sets up the backend config with your token. And since we're using the ops instance, ops.gitlab.net, you have to have this environment variable GitLab token ops. So when you're doing this locally, that's the first thing you have to do is do a Terraform init. And then you just give it the environment name, which is gstage. And you can see here that it's using the GitLab Terraform state for this. Okay, so the state's initialized. Now, if I do a Terraform plan right now, it'll be clean because this is already run in CI as is. To create a new cluster, you have to create a new Terraform file. So I'm just going to call this jarv.tf. And I'm going to use the sandbox as an example. Let's call it test.tf. So I'm going to call this jarv cluster. I'll give it a name, jarv test 1. And that's all you need. So what this does is this pulls in a module called cluster that's also checked into this project, which then references the get module, which provisions all of the infrastructure. So if I look at this cluster main, there isn't much to it now, but you can see that it uses the get module for the reference architecture for GCP. And I have 3 console nodes, 3 Postgres nodes, and 1 PG bouncer. So what will happen is after I apply this, those resources will be created. The idea here being that eventually, like as we build out each cluster, this will we'll probably pull in what we need or what we can from get, and anything else we can just add this or push it upstream to get. I'm going to have to do another init, I think, because, or maybe just a get, but it should be fast. Okay, so now I can do a Terraform plan. And that's it. So this creates all the infrastructure. So this is pretty simple, but what's cool is to see this happen in CI. So what I'm going to do is create a branch. And I'm going to check in my cluster. And then we'll flip to GitLab. So the way we have this configured is that we have the code checked in on GitLab.com and the pipelines run on ops. Notice that like these images are rebuilding. I'm just going to cancel them because we don't want new images. And so now I need to go over to ops, which is where this code is mirrored. Yeah, this is also, for some reason, my rule for when to rebuild the images is broken. So it's trying to rebuild them even though when it shouldn't. But normally, like if you update any of the requirements, like the version of Terraform or the version of Ansible, it'll rebuild the image. I put this in the notes. Initially, I had one image, like one big image that contained both Ansible and Terraform, but it's huge. It was like 600 megabytes and was really slowing down the pipeline. So I split it into two, one for Terraform, one for Ansible. The Terraform one's only like 60 megabytes. It just makes things go a lot faster. So you can see the stages here. We have the image stage, which like builds the base image. Then you have prepare, which does all the initialization. And then you have the build. I use the GitLab managed Terraform wrapper script. I built that into the Docker image, which sets it up to use like the Terraform state on ops. So as soon as this completes, we should see in the plan, you should see the same results. And the idea here is that, you look at the plan and then you merge it to master, and then on master, it will run the apply. Go faster. While we're waiting on that, I can show you a nice cool feature about this is I created the sandbox environment, and the sandbox environment just has one cluster defined, and it's a child pipeline trigger. So you hit the play button here. And what it does is it creates a child pipeline on your branch, which does the initialization, the plan, and the apply, and it destroys it at the end. So what I'm envisioning here is as we add more features to this, as we add Ansible configuration, we can do the init, the plan, the apply, and the configure, run some inspect tests or run Ansible to do some validation testing, and then bring it down. The downside of this is that there's only one sandbox environment, so people could potentially step on each other. So that's not too nice, but I think we'll see how useful it is. So this will do basically the same kind of thing, except it does it in the sandbox environment. It'll actually build the infrastructure and then tear it down. So we see that the staging plan completed, which will be like the same thing I saw locally, which is creating all the Patroni servers, creating the PG bouncer and console nodes.
Jarv, about the sandbox, quick question.
Yeah.
This is in a separate project, right?
Yeah.
If it's in a separate project, then you can do concurrency of one for that specific runner. So you can actually queue up all of these things. Now, the problem is that, you know, if you have 5 engineers work on this and trigger 5 pipelines, all 5 of them are going to expect immediate response. But at the same time, you can make sure that things are going to be sequentially executed.
Yeah, that's a good idea.
And this is a good idea. I like it. I think it could even be like a more complex rule, not to be a manual, but like create some rules when it should be automatic. But this is a great step.
So this time we'll also apply in a sandbox environment the VMs. I'm hoping that this succeeds. I'm not sure if it will or not. We'll see.
Do you think that might run the risk of being a very long process to create stuff, configure stuff?
Yeah, especially like, you know, going through the configuration. This is why I made it a manual job, thinking that we would occasionally do it. Maybe like, obviously, like if you're adding a new database shard, then maybe you wouldn't do it, right? But if you're changing your Ansible configuration or Terraform configuration, then you probably would do it because you actually need to confirm that, you know, new infrastructure is being brought up.
Right.
That's kind of the idea for now. But yeah, hey, the Terraform run completed successfully. I was really like hoping using Terraform managed state on GitLab that I'd get the nice MR widget. Unfortunately, because we commit code to gitlab.com and our MR is on gitlab.com, we don't have that benefit. So maybe we can figure out something else. I was thinking like Woodhouse could maybe post back to the MR with the Terraform summary, but we do lose out on a little bit because of that. After the applies done for the sandbox environment, then it just does a Terraform destroy at the end.
Hey, Jarv.
Yeah.
I have a question about the sandbox. I'm not sure if I missed the explanation earlier. Where the Terraform state will be stored for this particular environment?
It's configured, or it's stored in an object storage bucket that is in the ops environment because it uses GitLab managed Terraform state, which is a feature. So when you configure Terraform, you're telling it to use the GitLab instance, and the GitLab instance is configured to use object storage. So it's a single bucket that's indexed, like the object is like, there's an object per, or there's like a directory per project, and in there's a key for each environment. So this would be using the sandbox key. Does that answer your question?
Yes. I was just thinking about the case where multiple engineers are working in the sandbox.
Yeah, so that's a problem. And like what Maren was saying earlier, like maybe having a runner with concurrency of 1 would help with that. It does use locking. You can see here, like this is the state file. So it's like, you know, using the ops instance, and there is a lock to prevent possible problems, but you could definitely see all sorts of badness, like with, you know, you have 2 pipelines running simultaneously, both of them hit the manual job to apply the sandbox, and like the environment's getting destroyed as someone else is trying to apply it. It wouldn't be good. So we'll need to figure out how that will work. Cool, and that's the end of the demo. I'll go back to the document if there are any questions. No, no one has questions.
Thank you for the explanation.
I was thinking of something. So you showed that there's like an intermediate model. There's from your jar environment, you pulled a module, and that module references. So in that one, you have a set number of console nodes and a set number of PG bouncer nodes. Can those be overridden if we want different numbers on staging and on production, for example?
Yeah, that's the idea. So I guess what I was for the setup of this, I was thinking, let me look at the sandbox since I checked that in. So this is the module you would define, and yeah, and you don't really set any options by default, but if you go into the Terraform module cluster, you can see like you can set, well, no, sorry, my mistake. Like, yeah, these are hard coded now, but we could make these variables. Like,
okay,
yeah,
that was my question.
Yeah, sorry.
That was intended.
Yeah, so the idea is to like use sensible defaults here, and we can. I imagine that this module will start to get more complicated as we, like, basically it'll try to leverage get as much as possible, but for things where we can't use get, we'll just define our own, resources here. And if you didn't see the note on get, like for now, I'm just baking get into the image itself. And when you run things locally, you have to create a syn link. And I'm still working or still trying to think about how this is going to work for Ansible. But I think that'll come next.
Okay, thanks.
Any other questions?
When you're talking about the Docker image being massive, was that because you're building Ansible from source?
Yeah, I think that's the reason why. I think if I used a pre-built image that had Ansible, it'd be a bit slimmer, or maybe I can figure out a way to slim it down. So I'm building Python for one, because it's using ASDF as like the source of truth for the Python version. So it's doing an ASDF install, which builds Python from source, and then it does a pip install of whatever Ansible version you have specified in your pipenv file. Maybe there's a better way to do that.
Well, yeah, I've had the same problems with specifically with ASDF and Ansible. For Ansible's piece on Alpine, there is a pre-built package. It's not always the latest and greatest, but it's always a little bit behind at least, and it seems to work. But obviously, it's still dependent. We're still dependent on a package and on the repo. That's a lot easier. That path. That's what we do in our pipelines. But yeah, all the other paths to try and get Ansible to Docker image are painful, and they are quite heavy, unfortunately. For ASDF, it's the same situation but worse because there isn't a package for it on repos out there. In the end, I just actually circumvent it by if you look at my pipelines, all I do is I read the tools versions file for the version number with regex, which I don't like, but it works.
Really?
And I literally just download the Terraform package, and because it is just a binary for Terraform, and I just put it into bin.
But why wouldn't you just use install Terraform with ASDF, which does the same thing in your Docker image? Yeah.
But then you'd have to install ASDF, which brings in Python and all that.
No, it doesn't. It doesn't. It doesn't bring in. Yeah, I mean, you can take a look at the Docker file that I linked to and see what you think. For just Terraform, it's only 60 megabytes, so it's pretty. It's pretty small, and it installs ASDF. It installs the Python, or installs Terraform with ASDF, and it runs like I run everything as the ASDF user. But then for Python, it's a mess. Like for deployer, what we do is we use the Python image, which is pretty small, and then I install Ansible into it, and that's a bit more reasonable. I think it's like 200 megabytes or so, but Yeah, probably we'll need to figure that out. Make it
I have experimented with that as well, but even Ansible needs some native extensions to be built through Python.
Yeah,
so it needs all the build.
Yeah,
packages,
you probably went through the same thing I went through. Like, yeah, you have to install like a whole bunch of Alpine
C++
packages.
Yeah.
It even like Cargo and Rust is
Yeah.
a dependency. So it's like,
and then it needs like OpenSSL and stuff, and it gets painful quickly.
yeah,
So I just switched on the back end. But
yeah,
but yeah, I will be going to be looking, if we have time, we're going to be looking up doing an official Docker image for Get in the next release. That will, I'm not so obviously I'm not so bored about build time. I am bored about image size, but the idea would be a unified image. But I'll be looking into it more at the time. It is a bit confusing that no one's really cracked Ansible in an image in a nice. It's not an official one, which is the weirdness. Red Hat really should be making an official one. That would make life a lot easier. But yeah, I'll have a look.
Yeah, it might be worth splitting out Terraform. Although I think with Get though, you kind of need both in one image. I'm thinking like there'll be a Terraform stage and then an Ansible stage. So having like this very slim 60 megabyte image makes the pipeline run much faster because it doesn't need to pull down a massive image.
Yeah, I mean the plan is initially just to have a one image for to rule them all. But if that is looking like it's going to be big, then absolutely we'll look at doing official Terraform and Ansible variants. But I'd rather have it as one. But we'll see how we get on.
Cool. Great. If there are no other questions, point number 3 is just like what we're doing next. Point number 4, and you don't need to speak up here, but I'd love to get some more help with this. So if you have bandwidth and you want to help me think about how we're going to do the Ansible config, and I created issues for doing the cookbook audit to get a sense of like what's happening next is there's a lot of work that's independent of whether we choose to use Ansible or our existing cookbooks, like setting up these environments, setting up the VPCs, creating the infrastructure in Terraform. We're kind of getting to the point now where we need to make a decision on whether we're going to convert our base recipes and cookbooks to Ansible or whether we're going to use the existing cookbooks. And that's going to be a fairly like deep dive into all the recipes that run on the infrastructure and seeing how much we need to carry forward. So it's going to be a bit of a grind, I think, but it sounds fun to anyone who wants to join me. I'd be happy for an extra pair of eyes. That's it. If there are no other questions, I think we can end the call. Thanks, everyone.
Thank you.